2. 3. Getting better. He's drinking loud. Come back. Oh, I can't move. You don't want to see the camera. Sorry for delays, just getting set up. Always just getting set up. What we're gonna do today, I need some wine. Some wine. Got my chocolate. Drinking on my. I just bought a cheap mic. I have a mic at home. This is not home. And maybe I should have bought a stand as well. Stand for this thing. Let's move that. There. Yeah. Sorry for this, everyone. You might say I'm not prepared, but I'm prepared to be prepared. Prepared to eat white chocolate on camera. Okay. So yeah, I was just streaming in a coffee shop and it wasn't working for me. You know when you bought a drink or two and you feel like they want you to buy more, or you should go. I was feeling the weight of it, and I already bought like 4 coffees and 2 bagels today. I thought I'll get a bottle of wine for the same price. Say hello to the cat. Okay, so I'm just going to test my microphone so I can hear myself for a minute. 1 2 1 2, yeah. If it's coming through, I don't know. Let's just listen. Okay, so I'm just going to test my microphone so I can hear myself too low. 1 2 1 2, yeah. If it's coming through, I don't know. Let's just listen. That direction of my microphone so I can hear myself too low. 1 2 1 2, yeah. If it's coming through, I don't know. Let's just listen. That direction of my microphone. It's pretty weak. 1 2 1 2, yeah. If it's coming through, I don't know. Let's just listen. That direction of my microphone. It's pretty weak. 1 2 1 2, yeah. If it's coming through, I don't know. Let's just listen. 1 2 1 2, mic check. Testing the microphone. 1 2 1 2. This is what happens when you buy a cheap mic. Mic check. Testing the microphone. 1 2 1 2. This is what happens when you buy a cheap mic. Okay, I think the microphone's okay. It should be enough for a stream. But we do have a big problem, and that is it's not open yet. That Jesus juice needs opening. I need that 1 glass of wine. Okay, BRB. Shout out to my homie Dan with his 1 glass of wine. 1 wine glass. Dan's all about the beers. It's the strangest bottle opener you will ever not see. You spin it to twist it in. One way, right? And you flick the switch here. Let's have a look. Up. And you keep twisting the same way. Same way, and now the cork's coming out. That's some wizardry. Okay, cat, we're streaming now, so let's get them subscribers in. So this was how many? Let's do the conversion on this wine. Okay, let's 44 shekels. I'm going to see how much it costs in pound. £9, so what's that? Nearly $11. So average for like a working man's wine. Let's get some air in it. Very fruity. That's good. I'll buy that again. Shout out Herman. Mount Herman. Okay. Here we go. What was we doing? We're doing lights. Okay, we're on scene lights. So at the minute, I've got a sun, which is like an infinite light source. So you have your position of your sun, which is maybe just like off left, right, or east, or west, or whatever, relative. And then your light comes in, but it shines from that angle on everything, as if the distance is infinitely far away. So everything casts a shadow exactly the same, which is not realistic, but it almost is, unless your world's like as big as like a globe, where that would matter. So that's like an infinite light source, and then you have and we have like a directional light, it's called, which in a sense the sun is directional to the world at least, but it's not, because it's a ball, it goes every way, but it's directional to the world. But if you have a torch, really it shines just forward and it cones out, but it goes in a general direction. So I've just coded that and put that in the engine, but straight away there's some bugs. So we will see this here now is the cone. There's 2 cones there, and there's also some other cones moving. No, so these ones moving are, what lights are these? I'll show you. You see the red circle? Let's load up some more buildings. So there's like a red circle which is coming from those two here. It's coming from these two lights. Let me remove one. If I change the colour, is that going to adapt? Yeah, so white. You see there's like a cone. I think it's going up. Is it doing anything below it? No. So it's going up. What we want is, we want it to go down, to shine down. And its position should be, and position is vector 3. So we don't want it random. The GLM maths library vector 3. So across the X it can be just off in the world. And then I think to I think that's 3 high on the Y axis. And then to here start position. Let's just check that. I've also added a few tools for my few regulars, my few hundred, whereby, let's have a look. So we've got a grid now, which will be new for some of you, but also we can turn off most of the GUI or the UI, which is nice for, it's a bit sensitive on my keys being pressed down. When we render a full world, that'll be helpful. Go away, Windows. Okay. So let's get up some cottages. I think it loads up 7 at a time now. Was it 3? When I open a file, it just gives us a lot. And this is good just to render. Okay, so let's see if that light moves. Where's the light that's not moving? That's 5 high. It's here. And they should be shining red. Let's just change the colour. Oh nice, got a crash. Yeah, maybe that's like a pointer error. I'm not sure what it is. You're gonna ask me why I didn't fix that before I came on stream. Yeah, I fixed it many times. It only breaks on stream. You know the type. Okay, turn the lights on. We're gonna do it again. It just gives us a world to emit some light to. Okay. So the light is not going down, or is it? Let's have a look. Is it emitting up? Where is that red light going? maybe it's here. So the bottom two lights, oh yeah, so it is going down, as we can see here. So I'm going to turn the strength off of all the other lights in the world, and here, and maybe even the sun. So now there's two lights that are red. This one here, this is just a standard light moving about. Let's go green, okay? So one green, and another green. And it's lighting. Nothing above, I don't think, which is good. And you see it's like a cone shape here. So I think we have a directional light. And it's almost generating from a point. We might get a crash here. Just load up some more cottages whilst it's not crashing. I mean, that random really is random. It doesn't like to overlap. It gives you like a fresh. Okay. So if you're just joining in, we're looking at lights. If I take draw debug lights off, you can no longer see them. Turn them on. I'm going to add a few more lights to the scene. We'll go with purple. Now these will be moving lights. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we have a look around, we obviously have a purple scene, and this is just a good way to debug lighting, right? But if we go here, there's two lights that aren't moving, that are giving us. Is this one working? White, yeah. There's two lights overlapping here, but this is our lights. I think red is what we want. We've got two red lights. Set the strength down. Yeah, there's no red. Strength up, and then we have our red. Let's just remove 1, 2, 3, 4. Wow. 1, 2, 3, 4, 5. And above, there's no red going up, so we have a directional light. Imagine these blue orbs and these red orbs. Okay, it's just a red orb, but that could be anything in game. That could be a torch, and we're saying flash and shine down. But there's a cone as well. So if you look, although I'm not sure why the house is not more lit, like the roof. And I think it's getting its position slightly off. It thinks the light's further down. It thinks the light is like, look, they're overlapping. This was the one. It thinks the light is here, I think, at like 0. There. Interesting. Oh, this is good. So let me just, can I move them? Yeah. Okay, there we are. So now the lights are moving. But why would the roof not give me more red? The grid's in the way. We can move the grid. Move the grid. Microphone is just a bit far away. Okay, let's just check this out. So where is that sun gone? So why are you only... So the first thing to do is check the other lights and see if you see no roof seems to be lit up. Let's put the strength of everything back up. And this might just be the texturing. Let's go yellow on everything. This is not the sun, this is a regular light. Yep. That is definitely too bright there. So are there any yellow roofs? Let's go a bit more. 1, 2, 3. Okay, there's more lights in the scene now moving about. Yeah, none of the roofs are... Oh, is that because of the sun? So why are the roofs not being impacted? And I think I know why. I'm pretty sure it's because of the... maybe the texture. No, I think the sunlight does affect roofs. But you see the lights affect all walls. Ah, okay, so this one is impacted completely. And that's the sunlight. That's some strong light right there. Let's go back. If you're just joining with debugging some lights. Let's go purple and blue. Okay, so purple is doing the roofs for sure. Okay. Actually, it might be just the location. Somebody please tell me why the scene is so purple. By just using basic directional light. Hey man, yeah. So I have a sunlight which is like an infinite source, and then I have the, let me show you. Let me just remove a few more. Then we have some ball lights here. Are they being rendered? Yeah, you see the lights, so the little orbs represent the light locations, but they're just placeholders. And they are, how am I going to call those? They light up the whole scene. I guess like not a directional light, but there's attenuation, so there's drop off. So it's like a regular, it's like a small sun basically. It will illuminate everything. And then these two red ones that aren't moving are my newest type of lights, which should be directional, which are represented, excuse me, here. And so if I move one here and here and give it some colour, this little homeboy here, and some strength. We need green just to be unique. And the direction of the light. It's almost on the house there. me see. So we're gonna go to the next light here. Which color was? The color shining down. What's going on here? Hey, I'll go. I recognize that name. Yeah, I got so there's the sunlight, because I think my other lights, I don't know what category they're in, because the main lights that are moving around the scene, okay, it's blue now. I think it's just the other lights have been. I need to turn the brightness and the strength from the other lights to 0, 1, 2, and 3, or about 0. Yeah, we have green there. And the strength. But it's only lighting up the corner here, and not the flat. Maybe because it's lighting up the bottom. Let's check it out. So point lights. Yeah, so the main lights that are moving about, they shine in every direction. So I guess that's a point light, and there's attenuation, right? And then the other ones are spotlights for direction. So what we're gonna do is remove the other lights. Okay. So the sun, that's not actually the sun. It was just a name I gave it in the noob days. So these are the new lights. If I show you, it just has an is directional, and then the shader interprets it differently. Starting position and position. So starting position was for lights that are moved on a function around the scene. So I needed to, no wait, I don't want to give them the same position. I can move them, that's okay, I can move them. By the way, I've just bought a cheap microphone for like $20, I'm traveling. You can hear me okay? Or it doesn't feel great. That's because it's not great. I'm about to sneeze, we'll know then. By the way, where did that music go? Sorry to the homies. That's when I was testing the mic. By the way, I know some of you need to like the chat. You need to like this video because of that grid. Some of you have not seen the grid before. You'll be surprised at how many issues you can get trying to create a grid from a tutorial. So as soon as there's at least one model in the scene, the lights that are already coded, odd coded, will appear, but they won't turn on until I add at least one more, and now they're on, and so their brother lights should be, oh, I've just deleted those, right? Okay, so we just have the sun moving, and what I need to bring something over here. It should be lit up. Okay, so it needs to be below to be lit up. Let's see inside the house. Okay, so something's popping. Let's put the strength up, and the strength up again. We don't need a grid. So I'm trying to work out what's going on. So red light's working. Let me remove the red light. We've just got green. Now, does this need to be higher? Yeah, so it wants to be, because it's shining down. Where's it gone? Okay, so there's a bit of green. Now, obviously, it's interacting with the world. What I need is first the strength to. I don't know if that will wash out because shaders. Wash out as in it will just destroy the colours of everything. Everything will go white. And then what we need a different model that doesn't have texture. It's loading that model. Okay, I don't normally get loading that bad on something. I mean, it's quite a serious model. Can we get it over here? I need. So when I load a model, it loads in a random location. Actually, what I can do is add light. Add light to scene. And position. What we need to do is be able to move the lights a lot further and make them stronger for debugging. Okay. So where's everyone calling from? What's everybody doing? Okay, is that loaded? Wait, that's not good. I thought I just changed those. Maybe I changed these, yeah, for the new lights. Let me just make the text bigger for you. So what I need is, I need this code here. It's under settings and then sun Y. Okay. Maybe that's the name of the light, but let's try settings. And Sun X, Y, Z for each light. And position. Okay, so what this is us being able to move the light to any given space. And then this one is for the Y position, up and down, and then the Z position as well. So we can move lights through the world. This one is the strength of the light. Let's keep it at 3. Transparency, diffuse, ambient. Right then. Okay, I'm loading up some Bugatti cars. It's very warm. Why is it so warm? The weather today was 28 degrees. I've got the aircon on, but it goes everywhere but here. Moving. Oh yeah. Okay. So let's move a light, right? And then what I need to code, obviously, is the little tool that lets you drag something in 3D space. It will just move a model matrix. And the sooner I get that, the better. The light was shining down, I think. So if we go up on the Y, yeah, the car don't care, right? The car's not bothered about my light. And then, was it in the X? Oh. Let's get that strength right up, and then interesting. Oh wait, first I need to turn the lights on. Boom and boom. Okay, that's doing something. You can see a bit of red on the car. So now it's interacting with material. Obviously it's not going to make everything just red. If we go under it, there's no red. So it's if we go above it, it's shining down, so it's working. What we need is, we need something with less material. So I think this is working. So directional light, okay, this is the basics of directional lights in my custom little engine. I need an engine name, but what we'll do is if we do that and that. Okay, let's move homie up here and here and here. Still just not happy about how this feels. That's because it's very far away. It seemed as though it was next to it. I feel better now. Okay, you see? And I think it's just not high enough, actually. It's just not high enough. And the model. So the bit that's red there is because even though it looks high enough, I think it's not as high as we think. Where we see it, the ball, doesn't mean that's where it is. It just depends how you've coded it, good or bad. Can I say that? But also, feeling as though it still should. Or is it just only going down? I mean, it's only shining up. Yeah. So the direction of the light, I thought it was shining down, the direction is up. Let's bring Homie over here. And this is the other light interfering. Let me remove. Is it? Let me remove that one. Something going wrong. I need more targets, more trees. And there could be a few things at work here. Some of these trees have properties like reflection or not, and so it might not. It's not always our mistake. So you have to find out. Okay, so let's get the strength up of. And it might be the attenuation, which is where it drops off. So one thing's for sure is anything above like 0 is not being lit. So everything's shining from below. So the direction is up. And so we have a direction light. And maybe we just have it. Maybe we just have it. And where's the ball? Where's the actual light source gone? There. It might just be that where you have here the ball, it's not at the center of the light source. So that's not necessarily where the light source is coming from. That's a reference point. So that might be the top of the light source instead of the center. Hence we have still some light here. What's chat saying? I don't know if I'm cut out for debugging this. No more wine. No more wine. Okay, and my second one. Okay, so we have directional lights, which is pretty cool, actually. And now if I add a blue light to the scene, a strong blue light, Too strong. So these lights are like, it's like a point light, right, Homer? Where the point just lights up, I think from a reference, a space, not just up. But you see the green, what I want to show you is if I turn the strength down as well. The green remains, so these will go blue as the light comes and goes, or red. Look, it's blue here, but the red will always stay, or at least it interacts blue versus red. It's pink. So that's like your street light, or you're going through a forest and there's some stakes in the ground with some flames on. This is your point light. You got a tavern, you go inside a tavern, there's lights outside. There can be direction lights, there can be point lights as well. A torch, obviously. So what I need is, now I'm going to loop through the lights and we're going to say what kind of light it is. We're going to say we can change the type of light it is, and we're going to say we can change it, we can change the way it's going. What's the theme of the game? Good question. So right now we're just on the engine, as you know, but it's going to be like a world simulation. So you're not God, but you're the governor. You're God, and you're managing the civilization, the society, and I don't want to introduce combat until quite far through development, because then I'll be forced to make something original. So like Age of Empires without combat, or also it'll be like old era. It might be like fantasy, so there might be a theory in the woods. I don't know. If you've seen Sapiens, Sapiens, if not, check it out as a reference point. But humanity. But now it's just coding some basics. Okay, so let's if I minimize the engine and pause it. What, are you working on anything, Algo? You doing anything yourself? So what did we have there? Settings, right? Style settings. No, it was just settings for sure. Here. Water scene lights. Source dot GPU data. Yes. Okay. So what we need here. Actually, enjoy more farming and life mechanics of the game on fire. Yeah, exactly. I think a little bit of a cozy vibe. The word's been overused now, so what you need to do is like look behind that. Like, what's the rush? I get that. I think that's the whole thing of the cozy vibe games. Like, why rush? There doesn't need to be like a victory or a loss. Imagine just casually just growing your world, comparing it with others. Sorry, I forgot to turn me down. I was just saying, if you hit like, it will bring more people into the channel. Just the algorithm. It means I can feed my kids. If I ever have kids one day. I think we're good. We're good, we're good. And let's take tracking off. I think I hurt its head. I need a bit more wine. Come on. Oh, it's working. It's just it needs tweaking. Okay. What we need here, direction. Okay, let me just fix this. I've got too many cables. Sorry if I'm just staring into the camera. And we need that. Yeah, that will do. Why? still here, by the way. That would do us. Okay, that will go. That will work. And ChatGPT, my friend. When I first started using ChatGPT, I told myself I would never say thank you to it. But you just can't help it after a year. After it does more than your universities. Okay, really sorry, I'm just not prepared. Sometimes it's good just to get on stream. Maybe the first hour's rocky, but 4 hours later, you've got some progress. Okay, let's see what the loop looks like. Scene lights. It's a model after all. How do you mean? Directional light. Light name. Do we have a light name? Yeah. No, exactly. And it was more for me, like, I don't want to teach myself to say thank you to a... Maybe once I've said it to a cash machine by mistake when I'm like still asleep in the morning. But I mean, that's something you don't do. You might do it once in your life, right? But an LLM, I can understand people saying thank you or hi, please can you do that? I can understand that a bit more. But then a Tesla bot, a robot, we're just not going to be saying it. It's just going to happen. Okay, so if it's directional, if it's 1, then it will give us daylight and data. And then we need, we need the function. Okay, I think that's just ready raw. But I'm not sure I want an extra function. Update light and data. Yeah, it will, because I was quite strong that I would never say thank you. But it's like, oh, I'm learning to code. So then it's like, hey mate. Okay, update lighting. Array size. And why would we want that array size? Oh wait, is it taken out from every one? Yeah. Yeah, I need to really, because there's too many here. Just the problem is, why did it do that? The problem is some of the variables aren't that have the scope I'd need. Update lighting. Function to update the UI interface with light. types and positions. Uses SSBOs. Control and full stop will bring us this. It kind of gives it you automatically. That's control and full stop. And then do I have this data? SSBO lighting. I think I might have somewhere some pointer to some of my other scene lights as well. Great. So we're just going to pass this, right? A vector. I'm not making all these globals. Okay, so if you're just watching, there's different functions going on here. If this is, you don't understand what's happening, and this function will change where our lights are. It will change the type of lights they are, and the positions, which way they're facing, and it sends that data to the graphics card. And it's using a vector, which is like the collection of all our lights, but it doesn't really know what this means, scene lights, because it exists in another part of code that it cannot see. So there's different ways that it can access it, and one is to pass, when you call this function that manipulates the light, to send some information to that function, and you do it, it's called a parameter. You do it here. You tell it what you're going to send it. So you need to see what scene lights is, and it doesn't know, as we said. Come on, scene lights, are we in the right file? We can control and click now. So it's a vector, which is a collection of our world lights. And if we press Control and Z, it will go back to the last thing we changed, and then which is where we want to be. So we can say we're going to send you a collection of lights, and we'll call you scene lights, because that's your name. And if you put a ampersand here, it means a reference. It means that we're going to send you the originals almost. So if you change us here, it will change in the whole world. Otherwise, it'll only change a copy. And another thing we're going to send is an SSBO of lighting. Yeah, I'll go. Remind me what you're working on. I think. Did I just ask you? That could be interesting as well. And we're also going to send a shader, which is a program that runs on the graphics card. Most programs run on the processor, the CPU. A shader is a visual and a graphics program. So this is when you shouldn't have had a wine. Lighting. And then the name you put here is how you reference it. So then we go to Control F update lighting data here, and then we say what do we want to send here, SSBO lighting. So you want to send the lighting, and what was the other thing? Scene lights, lighting, and the shader, which ChatGPT can remind me what's called data. I believe it was new model loader, maybe dot shader program dot ID. Maybe it was, maybe it wasn't. Did you see Elon Musk's is unveiling? the guy who made iRobot had some comments to say about him stealing the ideas. Okay, this is going to explode. Careful, cat. Okay, what did I do wrong? I didn't update the original blueprint for this. It's going to be good to be able to change light type. And then I want some handles so I can just drag them around the world. Okay. That's not good, I can't see any, so is that because I don't have any models? I think it is. It better be that, yeah. I didn't want that kind of error. Directional light. No, why has it done that? Really, it's done that? So we should have. So we have two lights that are. Okay. So if I take it from 1 to any other number, or 0, it's no longer a directional light, so the red lights will start moving. So let's see if the red moves around the world. It's too strong. See this red house here. Is it gonna move? It's definitely moving. Okay, so we've made them into non-directional lights, I believe. I don't want two red ones though. Let's turn the brightness down of the world light. Let's move the grid. That's the sun here. Okay, so it's working. Now, if we turn these all into directional lights, I need to just, instead of swiping here, by the way, can you see? Yeah, instead of swiping, it should just be a box, but it doesn't really matter for now. Directional light, yes. Directional light, yes. Directional light, yeah. Okay, so they're all directional lights, which means some should have stopped. Is it still simulating them? That'd be interesting. Directional lights, because what it's got is it's still giving them, so they're still directional but they're moving, which I know why. There's a loop that moves the lights about, and if it's a directional light it doesn't give it any locations to move to, but we've changed it to a non-directional light, so it's giving it locations to move to. Now we've changed it back to a directional light only pointing up. It still has the location, so it's still moving around and it's still directional, I believe. Which is okay. If we make these directional, I think we can move the way they're pointing. So let's have a strong yellow light. Strength off the scales 3. I don't know where that one is, but if we change where it's pointing, maybe we'll get some yellow. Okay, there's some yellow. We're slowly changing where it's pointing. Now the best thing to do is, this is not the best way to debug, but if we turn the strength of the other lights really low, and so essentially it's mostly just a yellow light. And we can make the Y face the other way, that up or down. So now it's facing up, maybe, instead of down. There's anything above to see. Okay, so now Y, make it point the other way. So it's pointing down. Which light is it? It must be this one here. And then we can make it, this is like left and right. And forward and backward. Yeah, you see that, look? There you go. So it's pointing like down and towards the houses. Okay, so we have directional lights in the scene. Simple. And you can see it moving around. And down and up. I need it to be my own 4-bit CPU hopefully. For personal projects, I'm making a real time logic gate circuit. I need to remind. That sounds deep, man. Sounds deep. But I like that a lot. So the problem we have here is the orbs aren't taking the colours that they should. And let's add a red light to the scene that is strong. Too strong. It's just a standard point. Yeah. Is the green light moving? Yep. It didn't stop probably, it just probably stopped on one axis, so maybe it just moved in one direction. I've given these random directions just for the obvious, just to see it work and simulate. There you go. And if we bring it down into the light, no. Green on here. Sweet. There's still something not right. There's something not perfect. I don't know what it is. And if I minimize this, what we would do in the main code here, if I search for spheres, sphere.draw was it? Draw or debug lighting. Diffuse color. Maybe I didn't give them colors. Because the color's now in a different location. So what did we last change? It was add light. And here, what is color NL? Color edit. Okay, we did GPU data.color. Ah, it's here, I think. Lighting SSPO. I think I've lost a bit of code in my. Let's go back to. Scene lights. Maybe here. What was the last function we made? Here. Update lighting data. Scene lights. Yeah, this is wrong. We're not sending scene lights. We send the GPU lights data. These moving lights simulating the light going through clouds or just the sunlight? Wait, is my head really that big on the stream? I don't know what happened there. At least you can't, at least it's not on. It's also flip me, right? Did it flip me? No. So I have a sunlight which is like an infinite light, which is not any of the ones I'm interacting with. But I can change that as well in real time, somewhat. And then these are just two different types of lights. I had basically lights that were moving that were just lighting up the nearby area. It has an attenuation, so the further it gets away, it ceases to impact the world. But then I wanted lights that just point in just one direction, like a torch. So it's like a cone that comes out, which is kind of these. But because they're symbolising the world by a sphere, it doesn't look like it's a cone light, but it actually is, or it should be. Okay, let's, if I move it from being directional, it should give it some places to move to. So that light is now moving around and you can see it. And they're both red now, okay? Before they wasn't. And this one is like bluey green, as it should be. Yeah. Okay, I don't know what was wrong. I know the colours weren't working, but I think it's fixed some other things as well. I was sending the wrong data to the shader, but it adds some of the right data in, so it works a bit. Okay, so what we have is, we have 3 lights here. Now the blue one is going to be a light that shines in every direction, so it will move. The red one as well, and then this one is still going to move because it has the, yeah. Once a light gets turned into a moving light, and then it's hard to undo that. But it still does only shine in one direction. It's easy to fix in code, it would take me 1 minute. I'm just admiring the scene. So now they're all directional. They all now are facing just one way. The light will only shine one way from them. So you're not getting much light on the scene because there's nothing in their direct line of sight until they move about a bit. If I rotate that, it might pick up some light. And let's give some strength to the lights. It's going to make a big difference, I think. And let's go purple. And also directional. So the red light is shining sort of down, it seems. Or is it up? Yeah, some of the logic is off, I'm gonna say. which one did I just change? Let's take a red light. I might fix that bit of code. It's going to do me a favor. What did we call it? The function. Update lighting. Now what we need to do is since we dropped the camera, it's just not focused. I'm going to turn it off and on. Works every time until you drop it too far. Okay, let's get this back on. So what we want is the lerp here. Linear interpolation. Okay, what we want is if for each light, if the light.gpu.data. If it's become a directional light, if it equals 1, we're going to say light dot curve positions dot clear. So all the locations it's going to move to, if we've changed it back to directional, no, we're getting rid of them. It's not going to move. See if I introduced any bugs there. Usually happens, right? Cottage. And some trees. So we have how many lights? 1, 2, 3. One looks like it's probably moving. Yeah. Now if we change these from non-directional, it should generate locations and start moving. If we put it back, it should, yeah, it stops it. Okay, move it back. This just needs to be a tick box. So now it's not directional, or it is. Now it's not directional, but it's still the same color and the same strength, a lot of red. And this one can go. Okay, so we're going to follow it now. If we turn it back into a directional light, it's going to stop moving. And it's going to shine red. If we change the Y, it should be a different direction. It shines red, right? Come on, give me some red. Where's the strength at? Oh no, that's the green one. Okay, let's just move it. Yeah, so it's definitely you. There you go. Okay, there you go. Yeah. Red light. It's in the right location. Now it's not at the center. You see that circle here? You should really have the sphere in the center to help simulate. Because these, you see all these little circles, these lights that are helping us debug. That's all they're for, to help us. There's actually, if I press this button, it turns them on and off. They shouldn't be there. It's just to help see where they are. Helps you find bugs more. Let me just put a few more lights in the world to see what's going on. A yellow light, a little green light. Okay, we're going to stick with our red Homer. And let's move him on the x-axis. So the light is pointing in one direction. Now if we change him from a directional light, it should just be red everywhere and he's going to start moving. Come on Homer, get moving. Is that the right one? And maybe it should be, it's not on 0, it was this one. 1 will stop, so a red light stopped somewhere. Yep, there's the red light stopped. We lost track of it, and if I turn it to 0, it's no longer a directional light and a red light is moving somewhere here. What I would do is I'll turn the other one to green so we don't get distracted. Okay, so it's the other red one here. I make him non-directional and he's stopped. I make him directional and he's stopped. There's nothing for him to light up, or her, but let's see. It's the directions is below. So if we change the way it's shining, there you go. We're now moving. It's X and it's Y. So we're going up and down and left and right. It's working. It has all 3 axes. And then also we're going to say how strong it is. If we make the green one weak and white, the red probably be more pronounced. And that red one needs to be, let's have a look. A white one, I mean. Needs to get out of the way. Yeah, it's going now. So we have more red. Okay, so that's a directional light. It's a torch, basically. Now just remember the offset is a bit strange. What we need is, instead of circles, we need arrows in the world, and they also point the way the light's facing. I can do that another time, or just a pyramid, a triangle. And then we just say, look, you're no longer directional light, and now a red light's just going to go around the world again. Now in game, you're not really going to have a light that's directional then not directional. It's too strong. I can't think of why you would have that, but in the engine you might put a light in the world and then change its type, its purpose. Last bit of white chocolate. So really I need to tell ChatGPT to give me a switch. Instead of dragging this on and off, it should just be a button. Okay, what I want to do is just show you the shader code and just talk us through it a little bit. Model fragment. As best I understand it. Maths is not my... maths was my strength when I was younger, but at this level there's just so many areas I'm not familiar with. Okay, so this is the fragment shader which is responsible for the colours and not the vertices, not the drawing, but the painting, the colouring. So some objects have materials So the house didn't really have materials, it had textures. Like there was a roof. You saw the beams and everything. A material, there's the car, so there's the diffuse colour, which is its regular colour. The emissive colour, so like a lightsaber might have a green emission, it's shining out of green. The car might be certain levels of shiny, the windows a certain level of transparency. So you send a material to the shader within it's encapsulated, it's called, within a structure. It's all together. So what the window on the car, when we load it, will have these properties. And the specular, I think, is the shiny colour. Let's have a look. And then you create a material. Just because you have it defined here doesn't mean it exists. That's just that's how it sits in the computer's memory, with different variables: the colour, the emission, the shininess, transparency. But then you create the material. You say we want a material, capital M, and we will call it material. Simple. A uniform means that information is going to come from somewhere else. So we are going to send that information to this bit of code. So it's going to come from, you notice this is white, it's going to come, because that's a shader code, it's going to come from CPU code, which is not white. And then we have the same with a light, as we've just been seeing a structure. The light has a position, a strength, a color. It has, this is just padding, this just gives it space in memory. It's not important. The direction, it maybe has a direction if it's a directional light. And then you have a question, which is normally called a boolean, a 0 or 1, or a yes or no. Is it a directional light? If that's a 0, no. If it's a 1, yes. And a starting position. And then we create some lights, a given amount. At the given amount we send in a uniform, we say there's 10 lights. This code does it converts the time of day into degrees for where the sun will be. Yeah, it uses a sine, cos and sine, cosine and sine functions. Shout out trig. And then this is all sun. This is, we set some vectors, so we set some places in memory where we're going to store some light information. And then here, this is called a for loop. It means you're gonna do something a certain amount of times. How many times depends on the number that we send here via the uniform. And this is, we're gonna do something for every light we have. We set an attenuation, and this is, attenuation is almost the distance and the math behind when I need water, when the light, the power for when it gets weak. So if there's a fire, the further away you go, the less the light impacts the scene. And you change this with the attenuation. So first loop is it a directional light? And if it's not, we just do a little bit of maths. It shines in every direction, but we make it, as the scene gets further away, we make it less powerful. That's too strong. Some of those lights were strong. And then here, this is all shader code, by the way. This is GLSL. It runs on the graphics card. This is not C++, which is why you don't get the colors. Visual Studio don't know what's going on really. You can have a typo and it won't tell you. Not like although there's some programs that can affect that can help you. Here is what it does if it is a directional light. It gives it a direction and so on. Float max range, set the maximum effective range for the directional light. That's interesting because I mean obviously every light we can give different strengths. And the attenuation, the angle of the light, so there's like a cone, which is interesting. Like if your torch is pointing that way, do you want it a full 45 degrees? Like it can go all this way and all this way, everything. That might be too much. So you could narrow that down. But for debugging, we'll leave it as it is. That's it really. And that's not teaching, that's like a little heads up. That's just a little preview. But yeah, shaders is not my strength. Maybe C++ on a good day. So what I want to do is I want to go to ChatGPT, the Homer. And say, is there some VS Studio IntelliSense equivalent for GLSL? So it's not all white code. We want to see like, let's have a look. VS Code with GLSL extensions. Visual Studio, not VSC. It thinks we mean Visual Studio Code, different program. Okay, shader conductor. So let's find, stand still. And shader. So N shader was an older option, yep, and it's not working. And shader. Okay, I'll come back to this off stream. It's just interesting that there is there's nothing really popular. And also, who out there is using Visual Studio Code? Should I merge my app into VS Code instead of Visual Studio? That cat is drinking the water very loud. Yeah, so Visual Studio is not the only option, it's just good to know that VS Code is another one, but for C++, I think we're in the right place for now. Back to the stream. Okay, so we have directional lights. Let's go blue. There it is. A bit of red on the scene. I'm happy. We're working. Get that sun power down, move it away. And okay, we have a directional light. It's there. And then we can say you're not a directional light anymore, and it's just going to be a green light chilling. Blue and black. Which one is it? There. If you're just joining, or even if you're not, if you hit like, it will just bring a few more. It helps my algorithm. It tells YouTube to bring some more people in. Helps me get. I need 500 subscribers to get, so I can have Patreon, so people can join and be members. Why not? I think I just started like 3 weeks ago. Really, I hit the 3,000 watch hours, which normally takes 6 months, so I got lucky. But the subscribers, we're still hungry for subscribers. Okay, what can I add to the game? I think I need animation. I need some animation. And this is going to be more of a watch party vibe, I think. Because, why is that so much zoomed in on my big head? Gotta be real. That's a big head. Get rid of that, and we'll go here, and we will go straight to YouTube, and we will say async animation. And if I bring you in, okay, I'm just gonna watch this video.
Any animation on it, you should get it in bind pose. Once rigging and skinning have been completed, the model is ready for animation. Naturally, the same set of bones can be used for multiple sets of animation. Think about all the possibilities the human body provides in terms of movement and flexibility. All this is achieved with just 206 bones. Even with a small subset of these bones in a human model, you can still implement many animations. Therefore, each animation set will simulate some kind of an activity such as walking, running, fighting, etc. An animation set is composed of a series of transformations that are applied on the skeleton as the artist animates it. These transformations may include, as usual, scaling, rotation, and translation. In the case of humans and many other living creatures, we will only encounter rotation and translation, but the technique itself can support animated scaling of bones as well. The transformations will be provided at regular intervals according to some frame rate. For example, a 10-second animation at 24 frames per second will include 240 sets of transformations. These sets are usually very close, so if the actual frame rate in the game is higher than the animation frame rate, we can interpolate between consecutive transformations and get a finer animation. Since these transformations represent the changes in the orientation of the bones, we can apply them on the vertices that are influenced by these bones and basically animate the model. Okay, this is enough theory for now. I've left out many details that we will need for the full implementation, but at this stage I'd like to get our hands dirty with some code. Now, skeletal animation is supported by various file types, and if you implement a loader for a specific file type, you will probably need your skeletal animation code to adhere to the conventions of that file type. However, since we are using SIMP, we only need our code to adhere to the conventions and specifics of this library, and by that we'll be able to support many file types. As I said, we're going to implement this technique step by step in a hands-on approach, so let's create a simple utility that will parse the data structures created by SIMP and extract the relevant parts from it. Later, we will incorporate this logic into our OpenGL application. Now, this utility is not required for the actual execution of the animation, but will be very useful for debugging, etc. So this utility is composed of a single file, which I called SIMP sandbox CPP, and we've also got a build script in the same directory called the build SIMP sandbox to build it, and it is very simple. We have the build flags right here, called CPP flags, and for now I've included only -GDB3 in order to build it with debug information for debugging. And we've also got the link flags called LD flags, which is a call to package config --libs SIMP. I'm often using package config in my build scripts in order for my code to hopefully compile on as many machines and systems as possible. Polygons in the mesh, generate normals, and join identical vertices. We check for error, and we call parsing using the returned AI scene object plus the name of the CPP file, the compile flags, the link flags, -o, and the name of the binary. Okay, so now let's take a look at the CPP file. And by the way, I have a video on loading models using SIMP, so definitely check that out if you want more details. I'll go over the major details in this video. Okay, so first we need to include these three headers for SIMP. Okay, let's scroll down to the bottom, and here we have your standard main function. We're checking the number of parameters here, and it needs to be 2 because they pick up the file name of the SIMP importer class. Next we call read file on the find for convenience right here, and this is pretty standard. Normals and join identical vertices. We check for error, and we call parse
some load flags. Let's see what I've got. Cheers, man. Mom. It's been so long since I've used these flags.
Scene using the returned AI scene object from a read file. So AI scene is the main object that handles.
Let's see what we got here.
From a read file. So AI scene is the main
see all of that. Has cameras, has animations. Interesting. So let's init materials. Do I have an init material? No, that's the wrong one here. Init from scene, and we have AI scene pointer. So scene pointer dot, yeah, as animations. For control and click, it returns null, or if the animation is true, if there's more than 0 animations. Cool, makes sense. So yeah, when we load a file, we was loading objects like the cottage and the car. Now we will load something and we will run that function. Does it have animations? If so, we will then retrieve those. This is going to be an interesting, I don't know, month. I don't know about this. Maybe longer.
Object that handles all our interaction.
So we have has the array of animations. What does that mean? Does that mean every frame? Probably not. It'd be like maybe a parent, and then you get subsequent cameras.
With SMP, and it has several interesting functions as well as members that we can access. In this case, we're going directly to the meshes. Okay, there is an array of AI mesh object, which is where all the vertices live, and the indices as well as the bones. So parse scene is very simple. It just calls parse meshes with the scene object, and in the future we will have a function to handle the hierarchy and the animations. Okay, so this will grow and develop over the next few tutorials. So we have parse meshes here, and we start by printing the number of meshes in the scene object, which you can find in the mNumMeshes attribute in the scene. Next, we prepare a few counters for the total number of vertices, indices, and bones. We loop over the number of meshes, and we extract each mesh from the mMeshes array based on the index. We take the number of vertices, indices, fully. The important piece is here formatted. Next, we calculate the total number of vertices, mostly for bones, which we're going to print at the end of this function, and this is mostly for informative purposes, just to make sure that everything is working correctly. The important piece is here, where we call hasBones, which is a Boolean function that tells us whether this mesh has any bones in it, and then we call parse mesh bones on the specific mesh that we're currently processing. So now let's go to parse mesh bones, which is up here, and this is also very simple. We loop over the number of bones in this mesh, and we call parse single bone. Now if we run this right now, and I'll use a model which is checked into my repo called Bob Lamp Clean MD5 mesh, which is, by the way, from Doom 3, and you can see that it tells us that there are 6 meshes, and these are the names of the meshes. Okay, we have a body, a face, a helmet, grill, and another body, and for each mesh we can see the number of vertices and indices, and this is bones. You can actually see right here on the right hand side that these meshes correspond to components of the mesh inside Blender. So we have the grill, which this guy is holding, and we have the body. Okay, and this part of the body is actually the source mesh bones, which is right, and we're also passing in the index of the bone, which we will later see. Public does what it and it tells us that this matrix transforms from mesh space to bone space in bind pose. Okay, so this may sound a bit intimidating, but we will see how to use that in a future video. And the last attribute is the mWeights array, which is of the AI vertex weight structure, and this structure contains just 2 attributes. Okay, so every element in the structure has a vertex ID which tells us the index of the vertex that is influenced by this bone and the strength of that influence, which must be in the range 0 to 1 as we talked about earlier. So in the parse single bone function, we loop over the number of weights in the bone and we extract the vertex weight element from the m-weights array. And let me just uncomment all these printf calls were basically vertices that are influenced, and so we glance the bone out. And here's the next bind, 35. This brings us to the first challenge. Each bone is mapped to the vertices that it influences and manifested in the vertex shader position of vertex, to the bones that influence it. The transformation of each vertex will be covered in the next tutorial already. Thank you so much for watching, and I will see you in the next tutorial on skeletal animation.
Hit like, hit subscribe, and the algorithm will bring me more fun, more